I wanted to walk you through carefully this application exercise 2.7. Actually, I'm going to walk you through application exercise 2.6 and then do 2.7 that we didn't get to in class. We did a general case, but we need to do this one carefully. All right, here we go. So I've got the question. You've seen this before. Remember, it's the potato market. There's a equilibrium without a tax that we'll look at in a moment. There's a $3.50 tax. That's important. And then we're going to analyze the effect of the tax on the price paid by buyers, the price received by sellers, and on the new quantity. And I want to make sure you can do that carefully and well and right every time. Then we're going to do the welfare analysis, more practice with that. What I'd like you to do is stop this, pause this video and try to do it yourself, and then turn the video back on. If I can do it easily, I'll put that stop in there for you. There's supposed to be a way to do that in Moodle. All right, here we go. All right, here we have that market, and the U.S. potato market. I've got it a little bit scrunched in the pen that I use on my iPad isn't that precise, but I'll do my best. The key here, the key to analyzing the effect of a $3.50 tax, or any tax really, I'm going to use the pointer. What we're looking for here is, where is the vertical distance between the price paid by buyers, that comes from the demand curve, of course, that's where we have information on the buyers, and the price received by sellers. Where is that vertical distance equal to $3.50? Now, I'm starting at the right answer. That's probably not a good strategy. But just a lot of people's intuition, a lot of your intuition suggests that, a tax of $3.50, the price buyers pay is going to go up by $3.50. Sellers have all the power to pass this tax on to buyers. But that's not true. Notice that in this case, if price went up to $9.50, price paid by buyers went up to $9.50, price received by sellers would go down, what is that? That's pretty close to $5, and that's a $4.50 tax hit, and that's just not it. That's a $3.50 tax. So if we were anywhere over here, let's say we thought the price would go up to $8, or maybe a better guess would be the buyer and seller would split the tax evenly, $175 up, so $7.75. We'll notice that no, $7.75 down to $5.75, that's just a $2 tax. So there's only one quantity ever in these problems, only one quantity where the vertical distance between the price paid by buyers and the price received by sellers is exactly the size of the tax. Now here we have exact numbers. Usually, well, often we won't, and you just draw the graph and you show the vertical distance as being equal to whatever the tax is, tax size T. And you can do the general case. We did that in class. Hopefully you have that in your notes. All right, so now that we understand it, let's draw our answer in. So it's a little crooked, sorry. We see that price goes up to $9 per unit. The price received by buyers goes down from $6 to $5.50, and the quantity exchange goes to 350 million. I'm going to throw in a bonus here. I talked about it in class, but economic button on my screencast, economic incidence. What we mean when we say economic incidence is who pays what share of the tax. So the tax is $3.50, so buyers paid $3 out of $3.50. Usually we express that as a percentage. And, I don't have my calculator. Let me get my phone out. Actually, I'll pause it for a sec here. So that turns out to be 85.7% of the tax. And sellers, you only have to calculate with your calculator one side of that, because we know it has to add to 100%. Sellers paid then 14.3% of the tax. And we could, actually, I'll leave it to you as an exercise. Go ahead and estimate the price elasticity of demand on that demand curve and the price elasticity of supply. Actually, maybe I'll come back and do this in another screencast. I don't have time to do it here. I only have a certain time limit before I have to start paying for my ability to upload videos to the web. All right, so that's that. Now the next one, well, actually this one goes on because we did that for the first one, 2.26. 2.7 goes on, what's the welfare analysis? And I'll just recreate that table. Consumer surplus, producer surplus, government revenue, and then the total. These are our categories. And then no tax case and tax. And we always are interested in the change, which I'll represent by Greek letter capital D, Greek letter capital delta. All right. So when we do our welfare analysis, we first label areas. I've got a couple of inconvenient ones because they're so long and skinny. We first do the analysis, what's going to happen to the price, what's going to happen to the quantity, etc. Price paid by buyers, price paid by sellers, ABC. D is going to be this long, skinny area, and E is going to be that teeny tiny triangle, and this area down here will be F. So in the no tax case, we see that consumers got A, B, C worth of surplus. How do I know that? Because I know that the market cleared at 400 million sacks sold. The area below the demand curve, counting from 0 to the quantity exchanged and above the price, I end up with the area of this big triangle, otherwise known as A plus B plus C. Now, producer surplus in this case, remember that's the area below the price line and above the marginal cost, the industry marginal cost curve, which is the industry supply curve. We'll show that carefully next module. Anyway, that triangle there, below the price line, in this case it's a triangle, it's not always a triangle. Usually it is on these original cases anyway. DEF is my producer surplus, so I have to change back to my pen. There's no tax, so there's no government revenue. A, B, C, D, E, F. And you notice the total surplus always is the area below the demand curve and above the supply curve counted up over the units sold. All right, let's get a new pen, new color pen. In the tax case, we see, by the same reasoning, that consumer surplus shrank from ABC just to A. So people that buy potatoes are hurt. They have to pay a higher price for fewer sacks of potatoes. Producer surplus also takes a hit. Producer surplus goes down to area F. Producers didn't pay a huge share of the tax, so area DE, their loss is not super large. It's that long, skinny rhombus, I think is what we call that shape. And then government revenue, remember that the government collected the vertical distance between the price paid by buyers and the price received by sellers. That was $3.50. They collected that tax on each unit produced, and there were 350 million produced. So we could get actually the dollar revenue created by this tax by taking $3.50 times 350 million sacks per year. So in this fictitious example, this was a big revenue generator. But in terms of the area of this rectangle, the government collected B sub D, and we're assuming that the government is using that money to go help, go do something useful elsewhere in the economy, inspect food for E. coli or build a bridge or offer medical care to old and sick people, and build a national defense program, all these things the government does. And then finally we have the total A, B, D, F is the new total surplus. And let's see who wins, who loses. In consumers, lose area BC, producers lose area DE, and the government, taxpayers at large, citizenry at large, gains the ability to spend BD, hopefully on useful projects. And when we net all that out, we see that negative B, positive B, they cancel out. Negative D, positive D cancel out. We're left with negative CE as the dead weight loss. The dead weight loss is the difference between the efficient case and the case we're analyzing. So we've lost area CE. Graphically, we notice that the output between 350 million and 400 million would have benefited buyers more than it would have cost sellers. We didn't pick up that surplus CE. We lost it as dead weight loss. Nobody gained it. It just was eliminated by this inefficiency generating tax policy. All right. The other thing to note, I noted this in class, notice that I could have gotten the change in the total by just subtracting the old total surplus A, B, C, D, E, F from the new total surplus A, B, D, F. When we do that, we get negative CE. So one way to check your work, make sure the sum of the changes equals the difference in the totals. That should always be true. If it isn't, you made a mistake somewhere. And if you run out of time, just write me a note. I know I made a mistake, because that tells me you know what you're doing, even if the math didn't work out. All right. Incidence. Oops, I just hit weird. Now this last one, this last application exercise asks, should we conclude the tax on potatoes caused dead weight loss? Should we conclude that the tax on potatoes should be removed? Well, go ahead and read these options and then pause it and think about it. Yes, the tax squanders economic well-being and should be eliminated. No, the tax is necessary to fund government operations. C, it depends. If the surplus created by the government operations funded by the tax is greater than the dead weight loss, then the tax should remain in place. And D, it depends. If a different tax is possible and would cause less dead weight loss or even increase economic well-being, then the tax should be shifted away from potatoes. It turns out it depends on both C and D. We should analyze taxes not by saying, tax is bad, free market good, but by asking, what is the tax revenue going to be spent on? Is that something that's going to create more surplus than is lost in collecting the tax? If the answer is yes, there's an argument to do whatever we're talking about. But also, if there's a tax approach that would cause less dead weight loss, well, we should be looking at that tax approach rather than the one in question. So it turns out when we get to externalities, negative externalities, it turns out pollution taxes actually increase economic well-being in the system and collect revenue, and they're a far superior way to collect taxes. That lesson is coming.